So first, let's start with payload encoding with B64. So we go to our source code and let's take a look at this. So our main function is a little bit changed, but not much. So this part is we already know, like virtual alloc, virtual protect, and create thread. That's a known standard. The new thing is that we don't do copying, but we have a dedicated, a new function which is called decode B64. Okay, and we will analyze it in a minute. But that's where we do the decoding from our payload. And we, so let's take a look at our payload. Our payload is missing, okay? So first what we need to do is to put our payload here in an encoded format. So B64 encoded. How we can do that? So we can go to our folder, RDO 3, and there is a file called calc.bin which holds the binary version of our shellcode. Okay, it's our shellcode or payload. Now we need to encode it with B64, and we can do that in Windows using certutil program. It is used for basically managing your certificates in Windows. So there is an option called encode. You give it a file name of you want to B64 encode, and the resulting file, let's call it calc.b64. Okay. So the command ran successfully. Refresh, and we have our new file here. So let's open it, and this is our calc shellcode, which is B64 encoded. So we copy this part and we paste it here. Paste, and we have to just get rid of new lines. Okay, let's verify. Yep, looks good. So our payload is ready. So save, and now let's take a look at B64 function. So B64 function, it uses a crypto API from Windows, and specifically function which is called crypt string to binary, where you can use different encryption and encoding schemes, and the one we're using is crypt string B64. Okay, so what arguments this function needs? It needs a source, an address of a buffer containing a B64 encoded string, its length, and where the resulting decoded string should be stored, so in destination. So if we go back to our main function, our source buffer is calc payload, so this variable, which is global variable, and basically our shellcode will be stored in a data section. Okay, so the length of our calc payload and encoded calc payload, and the destination will be exec memory, which was allocated with virtual alloc, and the size allocated was exactly the same as calc length. So you need to make sure that these two the new buffer is at least the same size as the payload, the buffer containing our encoded payload. The second change I did here is I added to get car. I added another get car function, and the reason is that I want to run this code again in under the debugger, so you can see where when this what happens in the buffer, in the exec mem buffer, before and after decoding our payload. Okay, so let's compile it. So compile, and we can run it, implant.exe. Okay, we can minimize notepad. Let's run our debugger, attach it to implant, and let's take a look at these addresses in the dumps. So go to expression, paste. So this is our B64 encoded payload, or calc shellcode, which is here. Actually, it's a data. Is it? Yes, it is. And the second one, we go to dump number 2. Again, go to expression, paste, okay, and now it is empty. And the reason is it's empty because we are the program waits for a user to hit any key. We are here, and so we are after we allocated the memory buffer for our payload and decoded payload. So that is why it's empty. Now, if we run it and hit enter, please take a look at this area. So I'm gonna hit enter, and as you can see, the buffer has been updated. So we have passed through this function, which was decoding our payload from B64 to the binary, and we hit this function. Okay, so this is our shellcode. As you can see, calc.exe, but you can also verify. I have included the string, the shellcode as a string or a string of bytes. So you can even compare this FC4883E4, etc., etc. So it's our payload. Okay, so it seems it's all good. It's running, so it is waiting for the user to hit any key. So I hit the key, and our payload get executed, and the program finishes execution. So this is how you can encode your payloads with B64. There is one thing I need to mention here, is that B64 is a very well-known algorithm used by many malware developers, and it is not enough if you want to hide your payload from reverse engineers or AVA engines. B64 encoding is not enough to do that and to avoid detection. So if you want to use encoding without no encryption, you have to come up with your own algorithm for encoding. You can use XOR for that, which is basically encryption, but keep in mind that B64 is not enough to avoid detection.